Hello friends, let's take a look at the Leetcode problem minimum window substring today. The problem statement is given two strings s and t of lengths m and n respectively, return the minimum window substring of s such that every character in t, including duplicates, is included in the window. If there is no such substring, return the empty string. So in the first example here, there are two input strings given. S is the source string and t is the target string ABC. And the program should return the minimum window from S such that all the characters that are present in T, including the duplicates, they should be part of that minimum window. So when we look at this source string S, such a minimum window is this, where all the characters are included A, B, and C, but the length of that substring or the minimum or that window is 6. And then you also have another such minimum window B, A, and C, where even though all the characters in T are out of order, but there is no such restriction given that they should be in order. So they can be out of order. And so this is also another valid substring. But the answer that you should return is the later one, which is B, A, and C, whose length is 4, which is less than the previous one, whose length is 6. And so in the second example, you have source string as a single character, target string as exactly the same single character. And so the minimum window that you can find is that single character, A. So your answer should return A as the minimum window. The third example is, this is a negative use case where the target string is two characters, two A's, source string is a single A, and there is no way you can find out a minimum window such that that satisfies all the characters of the target string. And so your program should return empty string. So let's take a look at the approach, what approach you would take here, and then I will also review the implementation together. So let's so imagine that you have a source string here, right? And this is the blank space here represents any character in the source. Okay, you can imagine any character here, A, B, A, and so on and so forth. And imagine that you have another T, another string T, which also contains a few characters. Okay, it could be anything, X, Y, Z, anything. And so what your overall approach should be a two-pointer approach. Let's say there are 2 pointers that initially points to the start of the string, and you name them as end pointer and start pointer. Okay, and so the overall approach should be you keep on incrementing the end pointer until you get a valid string, valid such string. So let's say the characters are X, Y, Z here in T. So then end pointer continues to expand the window until it finds all the X, Y, and Z characters, and that becomes your very first minimum such window. Okay, and then the next phase is you start compressing the window by moving the start pointer, and then you continue to do that until the validity of the string is no longer the validity, until your validity constraint does not hold true anymore. And so at which point that resulting string becomes your minimum string. So you continue to do that this process until you reach the end of the string. Okay, so this is your overall approach. Let's take a look at it. Let's review this in the implementation. It will be much more clear. The main function min window that takes in two strings, the source string and the target string. And the very first thing that you do in the main function is you build a frequency map, and we store that frequency map in a hash map with key value as character integer. The frequency map will be for the string T, and then you use that frequency map to look up all the characters in the S if they are present in S. Every character that you process in S, if they're present in the frequency map, then you increment the counter. So let's go into that. So I have the next step after building the frequency map. I have 2 pointers here, start and end. I use the end pointer to expand my window. I use the start pointer to compress my window. And in this process, I will find the minimum window substring based on the criteria that is decided by the count. This count is a counter for the length of this my valid string. Okay, so so I have this while loop in a while loop, double while loop. In the very first thing, well, the first end condition of the while loop is that the string ended or not. So that's obvious. If the string ends, then that marks the end of your traversal, and you return the minimum string so far, minimum string seen so far. Min string is basically the min string seen so far, and you always update that as soon as you find the current minimum that is less than the min string. So in the first while loop, you have you increment the end pointer, right? And then every that points to the start of the string s. So initially the string end pointer points to character a, and then you look up into the hash map whether a is present or not, whether that character that pointed by the end pointer is part of the frequency map or not. In this case it is, and so if it is, then you increment the counter. Okay, and then you update the hash map to reflect the most recent state, which is you make it 0. You decrement the hash map for character a. And so once you do this, you increment the end pointer, and this while loop, it controls whether the counter has become equal to the length of the target string t. Whenever it does, as soon as it does, then you execute this part of this while loop. What that does is it starts compressing the minimum window. And what this means, count equals length, means that you just found your one valid window. Whether it's minimum or not, that will be decided by this inside the while loop. But after this execution, whenever you increment the count, when the count matches the length, you just found your valid window. And so let's take that example. So when this condition meets, right? So let's process the end character, right? End pointer. So you process a is part of the hash map. You decrement the value of the hash map. The hash map a becomes 0, and then you process, and then you increment the counter by 1, and then the next character in the source string is d. You don't find d. You don't do anything with the counter. You move on to the next character. Then again, similarly, move on to the next character. B is part of the hash map, right? And so whenever it's part of the hash map, you increment the counter as part of line 22, and then again increment and then update the value of the hash map, and then continue to expand the window. The next character is e. E is not part of the, well, first of all, you are, before pointing to the next character, you are going to check whether this condition meets. Here the length of the value of the count is 2, which is less than the length, and so you are not going to enter this while loop, and so you will continue with the while loop with an updated end pointer, okay, and which is still less than the string's s is length. And so in this way you are going to point to c now, and so you continue the process. You increment the counter to 3 now, and update the hash map with the character c. Decrement the value by 1, so the value of the character c in the hash map will be 0 now. And so in this way, the counters then and now the end pointer will point to o, right? And your while loop, you have a counter matching the length, and so you will enter this while loop. So and in this while loop, you update, you take a difference between the end and the start, and you update your min string. And then you in your min string, you have this the length of this string stored, and now you start compressing from the front. In this loop, you start compressing from the front, and what you do here is that you read the value of the character from the front, when you start compressing, you read the value of that character from the frequency map and then update the frequency map and also check the value whether that value is greater than 0. So if it is, then you invalidate the window. Okay, so whenever you invalidate the window, this condition will no longer be true. And whenever it's no longer true, you are not going to enter this. You stop compressing right then. And then you start expanding again. And you repeat this process until you reach the end of the string. And how does the counter help you? Counter help you to switch between the expanding and the compression of the window. You always expand from the end and you compress from the start. And how does the frequency hash map help you? It helps you to make a decision on when to update your counter. And so at the end of the traversal, the entire traversal, when you reach the end of the string, you return the minimum string seen so far. So that's about it. Please comment on the video, like the video, share the video. Thanks for listening.